Hi, my name is Zarina Aisha Miran. I am a network engineer, and today we're going to talk about load balancers. Let's take Kenny here. He wants to access www.abc.com. So he sends a simple HTTP request to the server and in return gets the web page that he desires. However, in a real-life situation, there are hundreds, maybe even hundreds and thousands of people just like Kenny trying to access a website in parallel. So, ask yourself, does that one simple server, can it handle all of those requests all at the same time? Well, the answer is no, because how could you expect a single server to handle that many requests? So what's the solution to the problem? We introduce a whole bunch of new servers to do the same job. Yes, correct. But how would people like Kenny know which server to hit? Well, the answer to the problem is that we introduce another server to sit in front of all these other servers, called the load balancer. The load balancing server is the one that will communicate with all the other servers. Based on a set of dependencies, it will decide which server to allow the client to connect to. To go into greater detail, it would use something known as an algorithm, a load balancing algorithm. An algorithm is just basically a set of steps in which a computer must follow in order to carry out an action. A very well-known load balancing algorithm that most devices use by default is known as the round-robin algorithm. The round-robin algorithm is a type of job scheduling algorithm, which basically just schedules an activity. The idea is that it passes each new connection request to a new server in line, eventually distributing connections evenly across an array of machines being load balanced. Now, that's all great. But what if the load balancing server goes down? What would you do then? Introducing HA, known as high availability. The idea is that you put all of your infrastructure, that means all of your servers and your load balancer included, into one data center in one location. And then you replicate this infrastructure in this data center in another location. And one becomes active and the other one becomes standby. So the idea is if your primary data center, which is in the active mode, goes down, then your secondary data center, which is in the standby mode, will become active. The great factors of load balancers is the fact that they 1. Ensure high performance, 2. Great scalability, and 3. As I just explained, high availability. However, one of the downfalls is that if you were to make a change on one of the downstream servers, you would then have to make that same change on all the other servers as well as the load balancer. The popular load balancing vendors out there in the market right now would be F5, Big IP, LTM, Radware, Barracuda, and open source technology such as Nginx. In summary, Kenny, along with everybody else just like him trying to access that one website at the same time, can now do this at ease with the introduction of 1. Load balancers and 2. Load balancers in 2 different data centers operating at the same time. If you have any questions, please leave your comments down below. Otherwise, thank you for watching.